Hello. If you've ever tried to find a microphone for the home studio, podcasts, YouTube audio or anything like that, and you've searched online, you've almost certainly seen things like this advertised as studio condenser microphones for very, very low prices. And the problem is they are not condenser microphones in the way any kind of audio or studio engineer would consider them to be. They're a very, very different type of thing. The other thing is, a lot of them are advertised for things that are just not suitable for. I've called this why not to buy and why to buy a mic like this. It could also be called the great condenser microphone scam, because that's really what's going on with the advertising. There's multiple points. Firstly, these cheap things, I mean, this is branded a NEWA NW700. There are multiple brands, multiple names, numbers, but typically there's something 700, 800. There's a few, I think there's start 1,000 or something like that. But I mean, this complete kit is about £15, I think, something like that, or even less. It might even be £10, depending where you buy it. The problem is, well, one of the four problems, anything that comes with a cable like this, where you have an XLR socket on the mic, and then an XLR to 3.5mm plug, that cable is a waste of space. It will not work properly with either not at all or not with decent quality. And the only good thing to do with that is throw it in a rubbish bin. I'll explain that why that is in a minute. The microphone itself, if you use it on something that has a proper XLR phantom powered interface, such as one of these little Focusrite units or something like that, it will work. They're not bad. They're not good, but for £10, well, they're very good. They might not be good in absolute terms, quality and noise-wise, but for the price, used with a proper interface, they're pretty good. They're quite acceptable, especially for voice work or anything like that. Now, as I say, these are an advertising scam in a sense, because they're advertised as studio condenser. And this is a scam that extends not only these really low-cost things, but also to some big-name ones as well, unfortunately. The way they get away with it is an Electret mic, this is an example of a typical small Electret capsule, which costs literally cents if you buy them in quantity, pence, whatever. The technical name for one of these is an Electret condenser microphone. And in the trade, or any normal terminology, they're just called Electret microphones. But because they include condenser, the advertisers can get away with calling things that use them condenser microphones. That's the scam part. As I say, that's a typical small, I think that's a 9mm Electret. There's many different types and sizes. They go a lot smaller than that, and some go quite a bit bigger than that. That's another one. It's the same diameter, but it's a slightly different length. Now, if you compare that to what an audio engineer would consider a condenser microphone, just get this little box. That's the Electret. That is a condenser capsule, a large diaphragm condenser capsule. And you see they're rather different. I mean, this is a very cheap, somewhat poor quality one from an eBay supplier somewhere in the Far East. And I think these are actually rejects, possibly. As when you buy them, they tend to have little specks all over the diaphragm, and they've actually got bits of brass swarf or whatever from when they were made inside them. But if you're very careful, you can remove it with it and get them back to proper working order. That's a topic for another video. But anyway, you can see the drastic difference between these two. These run normally at somewhere between 20 and 50 volts bias on them. The diaphragm, you can see the gold disc or gold looking disc just inside the insulating rings. That's supported with a very, very small air gap over the brass block. So it's metallized. It's a plastic film of some sort. It's metallized on one side, away from the brass, presumably. The centre lead there connects to it. The common terminal ground, or whatever, is the brass case itself. And as air pressure causes the diaphragm to move, it changes the capacitance between the diaphragm and the brass block. And if it's got a bias voltage applied to it through an extremely high value resistor, the voltage changes as the capacitance changes, because the amount of energy stored changes with the capacitance. And if it can store more energy, and it's got a given amount of energy stored already, then the voltage drops. Or if the the capacitance reduces, the voltage increases. So it produces a voltage signal in proportion to the diaphragm movement. And this is one of the earliest types. I think these are actually invented about 1930 or something like that. One of the very early types of high quality microphone, and they are still in use today because they work so well. I mean, these are a lot newer invention, and the big difference is the diaphragm is made of an Electret polarized plastic. Basically, it's allowed to set or be, when it's molded, it's heated and recooled in the presence of an extremely high voltage field, and it takes an electrostatic charge whilst it's in a molten and semiconductive state, or a soft semiconductive state, which is then set into it. So as long as there's no current drawn, it will have a slight electrostatic field around the material. And using that near a backplate will also give a varying voltage when the diaphragm moves, without needing a high voltage bias. I mean, these run from, depending on the type, run from maybe 1 volt up to about 10 or 15 volts. They're fed through a resistor, and the small capsule type like this have a built-in field effect transistor. So the high impedance part that would need the weird resistors and things in a condenser microphone is all internal. Now, I'll take this apart and I'll show you what's in it. Come apart quite easily. Right. Oh, this is another problem with these. But let me just take the head off the thing first, so you can see the microphone capsule is inside it. I'll move the box from it. It's just getting in the way. Oops, like that. Right. So you can see it's got a big plastic shroud on a relatively small capsule. Also note it's got 2 terminals very close together in a little circuit board. If you look, it's just a bigger version of that. And the big plastic shroud makes it so if you can see anything through the casing, it looks an outline very much like one of those, but it's not. I mean, there is some argument that the shroud affects the audio because it stops low frequency pressure waves wrapping around the back and cancelling out. But I mean, I think it is largely for visual effect to make it look like something it isn't. And now the other problem with these very cheap ones is the design changes all the time on these, by the way. There's countless different variations of the circuit board to use in the things. I had another one that's supposedly identical a while ago that I modified for somebody, and that had 2 circuit boards in it. And the boards are also built to take different variations of circuit. You can see there's a spare position there for a leaded transistor, whereas the rest of it's surface mount. Now, the other big problem with these, especially these very low cost ones, is they use multi-layer ceramic capacitors. You can just see in there, these surface mount multi-layer ceramic capacitors in the audio path rather than just for decoupling. And the problem there is they are sensitive to flexing and vibration. I mean, I've not tried it with this one, but the other one I had, when I was messing about with it, trying to get the noise level and sensitivity and stuff, and I had it connect up to that all Focusrite interface, I disconnected one of the microphone cables, or the signal cable from the microphone capsule there, the red one, to see how much noise was from the electronics themselves. And I found that as I moved it and tapped it, it was still producing sound. And it's the capacitors flexing. I ended up almost completely rebuilding it, basically taking all the capacitors off and all the unknown transistors off, and carefully forming the leads on conventional components, plastic film capacitors and known good transistors, to replace those to make it work rather better. That can have a drastic effect. I mean, another problem is, let me get the circuit for these. I mean, there's so many problems I'm losing to what I'm doing. That's a typical circuit for one of these low-cost microphones. I mean, it's for a BM800. Now that shows the Electret FET separate from the capsule. That might be what that extra position's for on the circuit board. But you can consider those two to be the capsule. If it was a two-terminal capsule with a built-in FET, it would connect across these 2 points. That's the bias resistor that feeds it, and a coupling capacitor for audio through. Now, these capacitors, if they're ceramic, they will produce noise as it's flexed. Any of these, because they're all quite high value capacitors, 1 microfarad, which means they're going to be multi-layer ceramics. Now, the next problem is the series voltage regulator here has no filtering or decoupling on the output. And one of the simplest modifications you can do if you get one of these is find that point with the emitter of that transistor between that and these resistors, and put a resistor in there, say 100 ohms, and then an extra couple of decoupling capacitors like a big electrolytic 47 microfarad and a 0.1 plastic film to the negative or 0 volts internal connection. So this whole preamplifier section and then phase splitter is filtered and doesn't get the noise from the regulator, because Zenas are notorious noise generators, and any noise from that will pass through to some extent, even though it has got a filter capacitor directly on it. Now, the other big problem with the cheap ones, with this cable that supposedly allows them to work with a PC, is that the Electret capsule itself works on a low voltage, and a PC microphone input was originally designed and still works with a directly coupled Electret capsule. I mean, PC mics might look different, they might have casing and stuff, but electrically that's all they are. An Electret capsule to a plug. The negative of the capsule, the ground, goes to the body of the plug sleeve, and then typically in the computer side, the ring connection has a resistor to 5 volts, and the tip is the audio output. Some variations might have resistors to both and use both for audio, but basically those two connect together, and between them they provide a bias voltage and the audio output from the output terminal of the microphone capsule there. That resistor being in the PC. And that's all it needs to work. These, however, have high voltage drivers to work from the 48 volt XLR and phantom power system, and a series voltage regulator. Now I've redrawn that to try and clarify why this is so bad. This is the same circuit but rearranged with the lead. Those are the output drivers, two emitter followers, PNP transistor emitter followers that connect to the XLR signal, balanced signal connections, and also are the feed for the balance phantom power, which it doesn't show on that one. Typically there's two 6.8k resistors from the audio inputs to a 48 volt power supply that provide power without unduly influencing the audio. In this design, this is an adaptation, basically a very similar design to a classic design that's been used for condenser microphones and this type of thing for decades. And there's nothing fundamentally wrong with this design at all. The principles are sound. I mean, this is another version, but it's pretty much the same. It's the two emitter followers to the output. Oh, that shows the pull-up resistors. That's the part that would be in the interface or mixing desk or whatever it's feeding, and that shows the two feed resistors from the power. And it also even says that the 6.8 cable. Now, it's a classic design, it works. It scopes, I'm not sure what it's called, it's something like that. But if you try to use it like this on a PC, first of all, you've got this section that's dropping voltage. Then that feeds the ground or negative side of that, if you like, is actually on the capacitor, decoupled from true ground. It feeds an emitter follower regulator, series regulator with the diode, with the Zener diode there. So that drops voltage, and then you finally have the preamplifier and phase splitter, or the preamplifier being in that. In fact, is just a phase splitter. Now, the microphone itself needs some voltage to work, but that's in the bottom of three stages of circuits that lose voltage. So if it's on 48 volts, as it should be, then it's fine. That's about 9 volts coming out of that. It will work fine. You try and run it on a PC that the initial voltage is only 5 volts, and then throw a resistor, which feeds to one pin on the XLR through the cable. The voltage drops there, and drops through the load resistor, and you end up with next to nothing on either the capsule or the driver transistors. The voltage is just very, very low compared to what it should be. In fact, I'll actually measure it on that. I'm also got it in bits. I have a USB feed cable here. Interface. It should power up. Yeah, there we go. We've got 48 volt power. Right, take two. The interface is now connected to my laptop, which is on the floor under here. So now the thing is actually active on USB, and it should have the signal indication working. Let's see what voltage you get now. I find the meter again. Right. That's more like 36 volts at the input. That's more practical. Right. So it's operator error, not faulty microphone. Right. Let's get more it's visible. So, start again. That starts out at 36 volts. Move that across a little bit so you can hopefully see them both at the same time. Starts out at the inputs there at 36 volts. The collectors of the output transistors are running at 34 volts. There's still very, very little voltage across those. It's a strange design, this. There's only 2 volts across the transistors, so there's very little drive available on those. There's no range. The regulator input is at 34 volts. The regulator output, whichever it is 8.1. Yeah, so it's 8.8 volt Zener from the Zener. So it's just under 9.1, and then about 8 volts to the, at this point here, 8 volts to run the microphone, which is fine, perfect. So that should be working correctly and be very sensitive to audio. Bring the interface back into view again. So that should at some point on here start indicating sound. We've got to face the microphone. There we go. So that's starting to pick up audio at that. And if I turn it full up, it's very likely to overload, yeah. So that's working fine. Now, if this is connected to the PC input instead, so that's now the microphone input on the laptop, goes to this cable. Right. So remember, that starts now at about 5 volts on the equivalent of that point there. Then there's a series load resistor and a couple of capacitors inside the computer for the audio path. I believe the cable only connects to one of the 2 output wires on the microphone. That's visible. Yeah, so that's it. The ground connection is ground. One of the output wires is also connected to ground in the cable, and it ends up with just 2 volts at the input to the whole circuit. So we go through it. That point there now that feeds the input to the voltage regulator is at just 1.3 volts. Let's go into the voltage regulator there. Get a connection at 1.3 volts. Voltage regulator output 0.7 volts now. Just 0.7 volts to power this whole circuit. Remember, a transistor only starts to conduct at the base at 0.6 volts. So expecting that to work reliably is just crazy. The basis of this phase splitter circuit is that this base of this is biased to half the preamp supply, or half this section supply, and it should have then equal voltage across the 2 resistors. So as the transistor conduction changes, it provides opposite out of phase voltages to the 2 driver circuits. At this, the voltages are going to be silly. There's only 2 volts supplying that. Oh, sorry, no, less than that, isn't it? What is it? What did I say? Good connection on that. 0.74 volts. The phase splitter transistor, that's got no voltage on the collector. 0.4, 0.7 and 0.45. Now that's between the base and emitter, which needs 0.6 volts before it starts to conduct properly. And the voltage to the microphone capsule itself is 0.15 volts. So basically, expecting a circuit that's designed to work on 48 volts to work on 5 volts, especially when it's constructed like that with a series regulator, is absolutely insane. A lot of these actually use a shunt regulator, which rather than having different voltages there, these two positions are connected directly together, and effectively the Zener's across there. So that point is held permanently at the Zener voltage, which could be 9 volts, or it could be 5 volts, or whatever. And the input to the preamp is the same. So it bypasses that voltage drop, and it also means a lot more voltage across the output drivers, which means that they give a better range, better linearity. But I mean, on this cable, it's to a PC input is a joke. Anyone suggesting that should work ever, just forget it. It is crazy, and that's why they're a scam, and that's why you shouldn't buy the things if you ever consider using one of those cables for a PC direct input. If you want something to work with a PC, get a PC mic that's got a 3.5mm plug built in, or as a standard part of it, and not something that's got an XLR connector. If you want a USB mic, it's a totally different thing, because you can get USB interfaces with phantom power that will connect to an XLR mic. I mean, they occasionally appear quite reasonable prices second hand, or they're about £35, I think, something like that, new. But obviously that gives you a single channel connection only to a single device. I mean, a lot of it depends what your long-term plans are. If you want something that's only ever going to connect to a PC, just purely for working with that, then get either a USB one or something with a 3.5mm plug built in. And as I said, a PC mic that's an Electret capsule with a casing, obviously, but an Electret capsule and a 3.5mm plug, that should work far better than one of these things with its own lead. And I mean, I think some advertisers suggest you use a phantom power supply with the things in line with the connections, but it's still a bad setup. These are designed to feed a balanced system, not a single-ended system like a PC. It's just wasting money. If you want to buy one of these and something else, then get a proper interface like one of the Focusrite ones. Now, just to go through some more bits about the differences. So these are fake condenser microphones. They're Electrets. There are better microphones that are not too expensive. I mean, there's some Samson ones are pretty good. The Samson Meter, I think it is, that's a direct USB one that's gets good reviews. It's not all that expensive. It's a bit more than those, but it's not that expensive. You don't need any extras with it. It will just work if you only ever want it for USB. The problem is, if with USB, of course, is it will only work with a PC. If you're thinking of creating a better home studio setup, starting to use other equipment, any kind of mixing or multiple channel stuff, then you need XLR connected devices that will go through industry standard stuff. I mean, this is a Samson one with I've already taken it apart because it's quite awkward to take apart. This is a C01U USB. So that's a direct USB connected one. These, again, it says studio condenser. I'm not sure on that. I don't think they are. I think that I believe, I can't say for absolute certain, I believe, but this is a bare Electret type capsule without the FET in it, and then the FET preamp is on the first board there. It is well built. I mean, this is one of the key things with the bare Electret or condenser capsules. The output is incredibly high resistance, high impedance. Let's see if we can get the light right so you can see into this thing without messing the things up too much. If you look in there, hopefully you can just see there's a little white insulator just above my fingertip there. There's a little PTFE insulator with a metal pin in it. The capsule output and the gate of the preamplifier FET connect to that. And there's also, you can just about see, there's a red block thing in there, which also connects to the same point, which is a very high value resistor. I can't actually read it in this, and I don't want to take the board out. It's a bit of an awkward setup. Measuring the voltages, I can't find any high voltages in this. It only seems to feed the capsule at a very low voltage. So that does appear to be, or the capsule preamplifier and whatever, everything around that, including the high voltage resistor, all seem to be very low voltages. So I believe this is an Electret capsule. It's just a slightly better made one. And this is another Samson, a U03, which is a directional, the one we can change the pattern on, which has two capsules in it for the phasing. Get the thing apart. There we go. And these appear to be those same capsules as in bare Electret with direct output. On this you can see the high impedance construction a bit better. A lot of PTFE insulators with the two channels, and the 1 km, so that's a 1 gig ohm resistor, which is quite typical on this type of thing. Though the output then goes straight into an IC rather than a discrete FET. I'm not sure what that is again. It's difficult to read at the minute. The whole processing section on this is very different to the traditional circuits. And it's got extra filtering options and gain options and things. But these again, they're what I consider an economy mic. They're not apparently a true condenser type. This, in contrast, is an MXL 990, which you can get on eBay or even brand new very cheaply. They're cheaper than some of the others. I mean, I think you can pick these up for about £50. There's a kit with the cradle mount and everything. And this is a true condenser. It's a small capsule, not a big capsule, but it is a true condenser design. And the onboard circuit has a little tiny voltage converter, which is somewhere in this part of it with the two inductors there, which is, if we go back to that classic diagram, it's this section. It's a little transistor oscillator, a couple of inductors, and a rectifier that produce a relatively high voltage. Now, offhand, I can't remember what it is on this one, but it's probably between 20 and 50 volts, somewhere in that range. I mean, the higher the voltage, the higher the signal, but if you go too high, it can mess up the dynamics of the diaphragm because it's attracting the diaphragm all the time with electrostatic force. Now, this is one, again, it was surface mount, and on principle, because it was using some surface mount capacitors, I did some extensive modifications to it when I got it, and basically drilled out all the pads, or drilled through all the pads for the surface mount capacitors, and put plastic film capacitors in place to avoid any possible stray pickup. And I can't remember if I did that mod with the insulators as well. I know I've done that on some mics. I removed the onboard connections and FET and rearranged it to use the standoff insulators and separate high value resistors and audio coupling cap. Again, that's a small diaphragm one, and small diaphragm capsules are generally quite a bit cheaper than large diaphragm capsules. Out of curiosity, I'll just connect that up to the interface and see what voltage it runs on. Be a bit careful with the circuit board being loose, because that's attached through the same screws and spacers that hold the whole thing into its casing. Find where I put the meter. So see if I can get to this without damaging or shorting anything. And hopefully be able to see the contrast in operating voltage between this capsule. It's going to be one end of one of those high value resistors. There we go. 43.5 volts feed to the high value resistor that feeds the signal side of the diaphragm. What's the input? Yeah, that's the voltage from the XLR cable, phantom power. It's about 30 something volts, and the voltage to the capsule is higher. So you can see the inverter is working and boosting the voltage. And to go another level from that one, so it shouldn't get damaged. The one all that earlier, that's another MXL one, but this is a V87, which is kind of one of the top amateur grade mics you can get, and it's easily into the same range as professional studio equipment. You can see the construction is very different. It's not got the surface mount stuff. It's all discrete components. It's film capacitors to start with. That's the bias resistor by the look of it, that little thick film thing. 3 gig ohms, according to the writing on the back. You can just about see that. It's not clear, but it just say 3 gig ohms on that. Yeah, that's the inverter. That board is just purely the high voltage supply. You see the 2 inductors there, which are side by side, which give the feedback, and the diodes for rectification. And this has got some little multi-layers for smoothing, but they are purely power supply smoothing. They're not in the audio path, so it doesn't matter that they are that type of capacitor. Now, if I pull the top off of this, you'll be able to see what type of capsule it uses. These, I believe the retail price of buy one new, well, I mean the recommended price is something like 400. But I think they actually sell new for about 200 to 250 pounds or dollars, depending where you get them. And as you can see, it's a very, very similar capsule. It's the same construction, general design to the one I showed earlier. And although it's the outer rings are a bit bigger on this one, the diaphragm size appears to be identical. There is I can't remember what it is now. It's about 34mm, is it, something like that? There is a standard size for the large diaphragm, pretty much so, a common size. You can see the microphone outputs from that centre terminal, which is on the insulator, and the ground is from the body. The switchable pattern versions of these have diaphragms both sides, rather than just the plain diaphragm that side. They are conductive diaphragms, rather. And by combining them in or out of phase, you get different patterns, which is how that double capsule one works. But as I say, this is, for amateur use, this is about the best you can get in terms of a true studio condenser microphone. One of the things with these is, though, the downside of having a true condenser is they're incredibly sensitive to air movements and physical movement, because obviously the diaphragm's got next to no weight. It's very, very thin and very, very small gap between that and the brass block. it doesn't take much to make the diaphragm literally rattle against the block, and it causes thumps and distortion. I'll probably demonstrate that actually if we bring the interface back up. Let's plug it in. So that should now be live, if you like. Turn that up a bit. You see that's picking up audio now. Yeah. Just moving it relatively gently is enough to trigger it. Give it a little output. It's so sensitive, it's picking up background noise. You must use a proper cradle mount and breath screen with these. Otherwise, you'll pick up all the noise through the stand, using whichever that may be, and any air movements, breathing, just drafts through the open doors from quite a distance away will cause the thing to go with a thump and distort the output, or mess things up. The other thing is, just if you don't use a breath screen, simple condensation from your breath accumulating on the diaphragm will affect the frequency response. So you do need to be very careful with the things, but used properly, they're about the best microphones you can get. I mean, this is a V87. We're done with the case. Anyway, it's a MXL V87. I mean, they're patterned after the classic U87 studio microphone that costs somewhere around 3,000 or 4,000. And noise level, quality-wise, I mean, the noise level on these is incredibly low as well. I think they're rated at 7 dB noise level, whereas something like one of these things, or the other Samsons, I think they're rated at about 27 dB or something like that. The noise level is vastly different, the background noise that this thing produces itself. So you get what you pay for. But it's down to what you need to use. If you want something that can be used in an expanding home studio or other equipment in the future, make sure you get XLR connected devices and buy some type of interface. If it's only ever going to be PCs, then USB direct or a 3.5mm direct is fine. Just the weight, just for the chassis of the thing. This weighs about 3 times as much. It's incredibly solid. Yeah, that's that big heavy section at the bottom. That's the coupling transformer. So it's transformer output to a centre tap transformer and drive circuit. Okay, instead of direct drive. Not quite sure what that is. It might be screening over the FET. Anyway, I hope that's been of some interest. And I say that's why, if you want a cheap mic for XR, that's why you can buy one of these if you need to economise. Put the money to a good interface instead. And why not to buy one if you expect it to work with a PC direct with a 3.5mm cable, because it'll be a waste of space. Anyway, thanks for watching. Any questions or comments, please add them below, and please click the like button.